this is Wendy, and in this series of videos we're going to learn about iteration or looping. In this first video, we'll look at three kinds of loops in Java. In the second video, we'll look at nesting loops and other structures. In the third video, we'll learn how to use loops for data validation. And in the last video, we'll talk about some common errors that programmers often make when working with loops. Iteration is covered in Chapter 5 of your textbook, and Section 5.1 begins by explaining why loops are an important part of programming. Recall that we talked about the three main logical structures in programming: the sequence, which is a series of statements that execute in order; selection, which are the structures that allow your program to perform various actions based on certain conditions, in other words, if statements; and iteration, which allows you to repeat statements a set number of times. We often refer to the iteration structure as a loop because the code body of a loop repeats over and over again, and when you visualize it, it tends to show a sort of circular or looping motion, as you'll see. There are several different types and categories of loop structures in programming. For example, we can take every loop structure and classify it as either an indeterminate loop or a counted loop. Indeterminate loops iterate for some unknown number of times. For example, you might sip your coffee as long as there's coffee in your cup, but we don't know exactly how many sips that might be. It depends on the size of the cup, it depends on how much coffee you happen to put into the cup. It could take 20 sips or 50 sips, but the number of sips doesn't really matter because we only need to know when the cup is empty. A programming example of an indeterminate loop could be processing a file full of student records. While there are records, you read a record and then calculate the GPA and then print the student's GPA along with their student number. We would repeat those three statements as long as we had records to read. We don't know how many records there are, and it doesn't matter. We only need to know when we run out of records because that's when we stop iterating. Now, counted loops iterate for a specific or known number of times. For example, you might have an interval workout that you like to do with push-ups. You might do 3 intervals of push-ups for 45 seconds with a 15-second rest in between. So you would do a push-up interval and then a rest interval, and you would repeat that 3 times. We would count each set of intervals 1, 2, 3, and then after we finish the third set, we would stop. A programming example of a counted loop could be determining the average daily sales for a 6-day working week. You would retrieve the sales for each of the 6 days and then add the sales to the total sales. After the 6th day, you're finished retrieving and accumulating sales data, so then you can calculate the average as the total sales divided by the number of days, which of course is 6. Try this exercise. See if you can come up with an everyday example of an indeterminate loop and one for a counted loop. Perhaps there's some activity or process that you do in your everyday life, such as walking to work, folding laundry, eating cookies, reading a chapter in your textbook, or watching the latest videos on a YouTube channel that you subscribe to. Go ahead and pause the video, think of an answer, and then resume the video and I'll show you my answers. So hopefully you had a chance to give that a try. Here's what I did. For my indeterminate loop, I chose folding socks. Yes, I fold my socks. I know that's weird, but I have a lot of socks with cat patterns on them, so I like to fold them and then line them up in the drawer so they're easy to see, so I know exactly which sock is which, and it's easy for me to pick a pair of socks out. So when I do laundry, I have some unknown or variable number of pairs of socks. So while I have unfolded socks in my pile, I flatten a pair of socks on my working surface. I then fold the pair of socks together, and then I put that pair of folded socks back in the laundry basket. I repeat those tasks until I have no more socks to fold. So as long as I still have unfolded socks, I do those tasks repeatedly. I have no idea how many socks I have at any given moment. I suppose I could count them, but I don't really care. I just keep folding until I've got no more socks to fold. For my counted loop, I chose a typical short run where I do run and walk intervals. So I have repeat 8 times, run for 6 minutes, and then do a brisk walk for 1 minute. I repeat those 2 tasks, run 6 and walk 1, exactly 8 times. After the 8th repeat has been completed, that means my intervals are finished, and then I can start my cool down walk. Another way we can classify loops is as pre-test or top-checking loops and post-test or bottom-checking loops. This now leads us into learning the syntax of the 3 different loops that we're going to study in Java. The first loop we'll learn is the while loop, which is a pretest or top-checking loop. The general form of the while loop looks just like that. We call this loop a pretest or top-checking loop because the Boolean expression is at the top of the loop. Later you'll see a loop where the Boolean expression is at the bottom of the loop, but let's focus on this top-checking loop first. When the loop begins, your program will first check the Boolean expression. When this expression is true, you go inside the loop body and execute all of the code inside the braces. We often call this the loop block. Again, any set of braces is a block, so this is our loop block. Once you've finished executing the code inside the loop body, the program sees the loop block's closing brace. Then control moves back up to the top of the loop. The Boolean expression is then evaluated again. If it's still true, we go back inside the loop body and execute those statements again. Once we've finished executing those statements, we see the closing brace. That means it's time to loop or iterate back up to the top of our loop and reevaluate the Boolean condition. Once again, if it's true, we then repeat the statements inside the loop. We continue in this manner until eventually we're going to reevaluate the Boolean expression and find that it's false. In this case, the loop is finished and it terminates. Control then moves to any code that is after the while loop, which could be any statements after the closing brace. The key thing to remember is that the loop continues as long as, or while, the Boolean expression is true. As soon as the condition is false, the loop then terminates or stops. Let's manually trace an example. So we're going to assume for this example that when the user is asked to enter an integer, they're going to enter 4 for the value of num. So of course we want to keep track of the variable num, and it has 4. It'll probably stay that way, I'm guessing, for the entire program. By the way, you'll notice this thing, that's supposed to be the less than or equal to. When I copied and pasted the code, that's what it did. So I tried typing the code in here by hand, and it just kept doing it. I spent 10 minutes trying to get it to look like a normal symbol and whatever. I give up. But I'm pretty sure most of you know what that means. That's going to be my less than or equal to symbol. Anyways, so I've executed this line of code. The next thing I want to do now, I've got a variable called count. Very generic variable name, but that's okay because this is kind of a very generic example. And I'm going to initialize it to a value of 1. So that's done. Now I see my while loop. So I see while count less than or equal to num. It's a good idea to keep track of your condition in a loop as well. So count less than or equal to num. There we go. So we got it written here. Num, by the way, is 4. So we have to look at the current value of count. It's currently 1. Is 1 less than or equal to 4? Yes. So that's true. So right now the condition has a value of true. That means we get to go inside the loop and execute the code. I'm not going to check this off until we're actually finished the entire loop. It'll get messy if I check it off, so we'll leave it for now. So I entered the loop for the first time, and the first thing I see is a print line. It says to look up the current value of count, which is 1, and then concatenate colon, a space or 2, and the word hello. I'll do my output over here. So the current value of count is 1, followed by a colon, followed by hello, and an exclamation point. And because that's a print line, it means it adds a new line to the end. So our next line of output is going to go down there under the 1. It's always good to keep track. And so the next statement I execute is count plus plus. We know what this does. It's going to take my current count and it's going to increment it by 1, so it now becomes 2. This, by the way, is actually a counted loop, but it's still a great example of how a loop works. Now, when I get to the closing brace, that means the body of the loop is finished, and I now move back up to the top and I perform another iteration, or I iterate again. So to do that, I reevaluate my condition. Is count less than or equal to num? So I look at the current value of count. It has a value of 2. Is 2 less than or equal to num, which is 4? Yes. So this is still true. Then that means since it's true, I go back inside my loop and I'm going to execute this code again. So I print line, I look up the new value of count, or the current value of count, it's 2. I'm going to print 2, concatenated to colon, space, hello. Remember I left off down here under the 1, so that's where my 2 is going to go. 2, and then some spaces, which I didn't really put enough spaces there, but that's okay. and then hello, and then it's going to add a new line because that's a print line statement. You don't have to draw these little arrows for new line. I generally assume if you've got the next output on the next line, you knew there was a new line there. So that's my first statement inside the loop body. My next statement is to increment my count. So it's going to increment 2 plus 1 is 3. Then I hit the closing brace. I loop back up to the top, or I iterate back up to the top, and I must reevaluate my condition. So is 3 less than or equal to 4? Yes, this is true. So because the loop condition is true, I enter the loop body and I execute these two statements. The first one, as we know, is a print line. It says to print the current value of count concatenated to colon hello. The current value of count is 3. My last output left me down here on the next line. I should have left myself a little mark there, but I think you probably got the idea after doing it so often this semester so far. That's going to add a new line to the end. My next output will go down here on the next line, whatever it may be. My next statement inside the loop is count plus plus. So I take my count variable, I'm going to increment it by 1, so it's now 4, and I must loop back up to the top. Again, we are tracing this code exactly like our program would. I loop back up to the top and I reevaluate. You got to be careful. I'm going to reevaluate this condition. Is count, which currently has a value of 4, less than or equal to 4? Yes, that is true because 4, the equal to is correct. So 4 less than or equal to 4, yes. So I'm going to re-enter my loop. Print line, the current value of count concatenated to colon hello. I left off down here under the 3, so the current value of count is 4, concatenated to some spaces, and then hello, and that's going to add a new line to the end so that my next line of output, if there is any, goes under the 4. So the next thing, of course, we have to do is we have to increment our counter. 4 plus 1 is 5, so now our count is 5. Now, you know, hope you know, we're done. But the program does not know that. So the program sees the closing brace, it will loop back up to the top, and it will reevaluate this condition. It's not human like us, right? So it actually has to do everything step by step. So it reevaluates the condition, count less than or equal to num. So it goes and checks, is the current value of count 5 less than or equal to num, which is 4? No, this is now false. So because it's false, that means that the loop terminates. When this condition becomes false, we then jump to the closing brace and then start executing any statements after the loop. In this case, there's one statement after the loop. It says look up the current value of count, which is 5, and print it concatenated to colon spaces done. So we actually do get an extra line of output at the end. So that's how the while loop works. Note that it's possible that the loop's condition could be false as soon as the loop begins. In this case, the loop body is never executed. Let's look at an example. Here we've got the same block of code, except this time we're going to assume the user enters 0 as the input. So I set up my variable num just like before, and it gets initialized to a value of 0 because that's the user's input. That's done. Then I set up my count variable, which as before is declared and initialized to a value of 1. Then I have my while loop condition again. It's the same condition, so I'm going to evaluate that first before I enter the loop for the first time. Is the current value of count, which is 1, less than or equal to the user's input num, which is 0? So this statement is suddenly false. So because our condition evaluates to false, so while count less than or equal to num is false, what that means is that this evaluates to false, this loop terminates immediately. It actually never executes or never enters the body of the loop. So from here, we actually skip all the way down to the end of the loop, and the next statement we would execute is this last one, where we print the current value of count, which is 1, followed by the colon, followed by done. And that is the only bit of output we would get in this version of the program. So it is possible with a while loop that your loop may never execute if your Boolean expression or condition is false right away. Because again, a loop only executes while this condition is true. As soon as it becomes false, the loop terminates right away. It actually never gets to execute at all. one thing that you want to be careful of is a loop that never terminates. Let's look at an example. Again, this is, I don't know why it's doing this. I just spent another 5 minutes on this one. This is the not equal to there. So I don't know, it just automatically turns it into that. I'll have to figure out why later. I don't have time to figure this out right now. I'm pretty sure most of you are also familiar with that symbol, so I think we're good. So imagine we had this code here that it printed from 1 to 10 by 2s. So if we trace this code, first we want to create our variable count, which we initialize to 1. That's done. Then we have our while loop. So our condition while our count value is not equal to 10. So we're going to evaluate this right away. So we look at count, it's 1, which is not equal to 10. So this is true. It is not equal to 10. That's a true statement. So of course we get to enter our loop. All we're going to do is print the current value of count. Let's say this is my output over here. This is print line again. So every one of these outputs is all going to be on different lines. I don't think we have to worry too much about that. Then we have the statement count plus equals 2. So what we're doing is taking count and we're adding 2 to it. So that means our count now has a value of 3. Since we're done the body of our loop, we then go back up to the top and we reevaluate our condition. Is the current value of count, which is 3, not equal to 10? That's true. It is not equal to 10. It's 3, which is not equal to 10. So again, we re-enter the loop. We print line count. So we're going to print the value 3 on the next line, and then we increment count again by 2. So we're going to add 2. That's going to give us a new count value of 5. I think you can probably by now see what's going to happen. Once I've incremented count by 2, I then loop back up to the top. You can see why it's called a loop. If I kept my pen down, I'd be making a loop, right? I'd be making a circle. That's why they call it a loop. So I reevaluate my condition. Is the current value of 5 not equal to 10? It's so awkward saying this, but is the current value 5 not equal to 10? Yes, that's true. 5 is not equal to 10. That is a true statement. So we enter the loop, we print the current value of count, which is 5. We increment our count by 2, so that's going to make it 7. Almost done. And then we go back up to the top. We have to reevaluate our condition again. So we got 7 as our count. Is 7 not equal to 10? That's true. That means we're going to re-enter the loop. We're going to print the current value of count. That's 7. Then we're going to increment it again by 2. So 7 plus 2, I'm just going to go up here. 7 plus 2 is 9. If you can't see where we were going before, you can now, hopefully. So we increment it to 9, we loop back up to the top, and we have to reevaluate our condition. Is 9 not equal to 10? That is true. 9 is not equal to 10. So we're going to re-enter the loop. We're going to print 9, and here's where things get interesting. So we've got our count plus equals 2, so 9 plus 2 is 11. So the new value of count is now 11. So we loop back up to the top. We have to reevaluate our condition. So is count, which is 11, not equal to 10? Think about it. That's true. 11 is not equal to 10. That's a true statement. So we're going to re-enter the loop. We're going to print 11. We're going to increment it by 2. So 11 plus 2 is 13. Do you see now what's going to happen? I'm going to loop back up to the top. This is still not true. 13 is not equal to 10. So it's going to come in. It's going to print. I'm going to run out of room. It's going to print 13. It's going to increment to 15. Basically, this is going to go forever. This is what we call an endless loop. Or some people say infinite loop. Obviously, they mean the same thing in this case. An infinite loop as well. Infinite loop or an endless loop. Basically, it's a loop that never ends. This loop will go on forever and ever and ever because this condition will never be false, because count never reaches the value of 10. This is a logic error. So that's an error in your logic. It's a very common logic error. Not necessarily this exact way, but endless loops in general, they happen all the time. So once you save, compile, and execute a program like this one, you'll see that it just runs forever in your console. And you could just sit here and watch, I guess, if you had nothing better to do. Eventually it will crash. What will happen in this example is count as an int, so it will not be allowed to be incremented to a value that's, what's that maximum value for an int is like just over 2 billion and something, 2,148,000,000 and something. So as soon as it reaches that maximum value, it's going to crash because it can't hold a value that's that big. In other endless loops, you might end up with something called a stack overflow. Yes, that is exactly where the website got its name. A stack overflow happens when you're executing different instructions, it keeps track of where your last instruction was using something called a stack. And if you have an endless loop, your stack might get full. And so it's called a stack overflow. So your stack overflows. That's a very simplified explanation, by the way. It's actually a lot more complicated, but that's good enough. So as you can see, we are just going forever. Look, we're in the 7,000s already. So in Notepad++, if you get stuck like this in an endless loop, it's not that hard to get out of it. All you do is make sure your focus or your cursor, whatever, is inside this console. You can tell because it's kind of got a blue highlight there. And you just hold down the Control key on your keyboard if you've got one, and you press the letter C. And it may take a second, especially because I've been talking now for a while. There it goes. And eventually it will stop. So just hit Control C once and it will stop automatically. In other editors, it's probably similar. Some editors like IntelliJ, there should be like a stop button. So you can just press the stop button. NetBeans as well, there's just a stop button, and I think in Eclipse. So if you don't have a stop button, usually Control C on your keyboard will terminate a process that's stuck running, like this one. Okay, let's try an exercise. Let's write a program that asks the user, oops, there's a typo, that asks the user to enter a series of test scores so that we can calculate the average. Now, we don't know how many scores the user wants to enter, so in this case, we'll just have to prompt them after they enter each score. So our IPO chart for this question, as usual, we start with the output. So what's the output to this program? It's the average of all the scores that the user entered. What inputs do we need in order to calculate the average? We need every single test score that the user wants to use in their calculation. We don't need them to enter how many. I'll show you in the code when we write this program. We can figure that out ourselves fairly easily. The processing, how do we convert each test score into the average test score? Well, as the user enters a test score, we are going to add it to a total variable. And then after the user has entered all of the scores, we will then calculate the average as the total divided by the number of scores that the user entered. Now, our processing section has two tasks. We need to add each user entered score to a total, and we need to calculate the average. Let's look at the first task, adding each score to the total. To do this, we're going to need to do three things. We're going to need to ask the user for a score. Then we take that score and we add that to the total score. And then we ask the user if they want to enter another score. Now we'll have to repeat those three tasks until the user does not want to enter scores anymore. So we can assume we'll just ask the user, do you want to enter another one? Yes or no. And then they will type a yes or a Y if they want to add another one, and a no, or we'll just assume anything that doesn't start with a Y if they do not want to add any more scores and they're ready to see the average. So we could write some pseudocode that looks something like this. So I've got the code to print a prompt, enter the score. I then am going to have some code to retrieve the score. Obviously in Java, we would use a scanner. So I'm going to retrieve the score and store it in a variable. Then I'm going to take that score and I'm going to add it to a total score variable. Then I'm going to print another prompt where I'm going to ask the user, do you want to add another score? Yes or no? Again, I'm going to assume if they type anything that starts with a Y, that's a yes. But if they type anything else, it's a no. And it's just easier in the long run to do it that way. And then the last thing I'm going to do is, of course, get their answer to this question as a char, whether or not they want to enter another score. Now again, I'm assuming user answer is going to be something that starts with a Y, so the letter Y for a yes, or anything else for the value of no. This is a very common thing that we used to do in console programs. That means we know that we want to repeat that set of statements as long as the user answer is a Y. So I would have some kind of loop structure. We're obviously going to do this with a while loop. This says repeat this while the user answer is a letter Y. And I will repeat this set of statements until the user enters something that's not a letter Y. As soon as they enter something that's an N or anything else, this loop will terminate, and then we can go ahead and calculate the average score. However, where does the number of scores come from? Like, how do we know how many scores the user entered? We still haven't figured that out. What we're going to have to do is keep track of that ourselves. So each time the user enters a score, we will increment a counter. So here I've created a counter variable called number of scores. I initialize it to 0 because I guess it's possible the user might not want to enter anything right away, so we might have no scores. And then inside the loop, when the user enters a score and I add it to the total, I'm going to increment the number of scores by 1. So what this will do is when the user enters a score and I process that score, my number of scores increases. So for the first iteration, it's going to be 1 because I'm going to add 1 to 0. For the second iteration, if they do another one, it's going to be 2. For the third iteration, it'll be 3, etc. At some point, I'm going to ask the user to, if they want to add another one, they'll say no. So when that happens, user answer is no longer a Y, the loop will terminate, and it will then execute the calculate average score as the total divided by that number of scores. When this loop terminates, number of scores contains the total number of scores the user entered. So it works perfectly. So let's go try coding it. Alright, so I've gone ahead and set up a program with a scanner, obviously, because we're going to be doing user input. So when I think about the logic, the pseudocode that we had on the slides, we know we're going to need a while loop, and we know that we're going to need some variables to keep track of things. So obviously one of the things we talked about is we need a variable to keep track of the number of scores that the user entered. I'm going to initialize this to 0 because before I start asking, I have 0 scores, so it just makes sense to initialize that to 0. And we're counting, so it's going to be an int value. Another thing I'm going to need is I'm going to need a variable to keep track of the total score. When we think about the actual score data, it is possible that they could have decimal values. I suppose you could always ask your client if you're not sure, but if you ask students, they will say a decimal value because, you know, let's face it, if you had 24.5, that's a lot better than 24. Let's assume that's at a 25, so we're thinking positive, right? So if you had a 0.5 or a 0.9, obviously you want that, right? You want that to count. So we're going to make the total and the scores themselves a double. So I'm going to create a total scores variable, and that's going to be to keep track of the total scores that I'm going to use later to calculate my average. You can create your average variable here if you'd like as well. So I can do a double average. I'll just do AVG score equals 0.0. Some of you know you can declare variables on the same line. If you want to do that, that's okay, as long as you document properly. And then one of the other things I'm going to need, obviously we talked about how we're going to be using this while loop. So I type in the while, get all the brackets and braces in right away so you don't accidentally mess them up. If you want to put a little tag there and the while loop to make it easier, that's totally fine. I recommend if you're new to this type of syntax, then by all means, make it easier on yourself to help you find errors later by putting little tags with comments at the end of each of your braces. That's totally okay. So back to my while loop. So my while loop, we talked about how in the pseudocode, we want to loop while the user says something that starts with Y to the do you want to enter another score. So we've done this kind of thing in the past, and we've always kept track of this as a char. So if I have a char and I just call it another, like you want to enter another one, and I continue as long as, or loop while another equals the letter Y, then that means this variable right now it doesn't exist. I'm going to have to create it. So I'm going to need to create that another char variable before the loop begins. Now, because I'm using it in the while loop here, you are required to initialize it, because otherwise when you compile, Java will say you can't do this because another was never initialized. This is a key thing with a while loop. You'll see later with a do while loop, this is actually less important, but with this while loop, you need to initialize it to the value that will get it in the loop. If you initialize it to anything else, you won't be allowed inside your loop. and you'll never get to ask the user for that first score. This is actually one of the challenges of working with this top checking or pre-test loop. It actually is quite a common issue. So again, when we look at the other kind of loops, we'll see how they're a bit different. So we do need to initialize the variable another to a value that allows us in to the loop, basically. It's totally normal. This is not, anything bad or anything like that. This is a totally normal thing. So once we've got some of our variables set up, you might have other ones you might be thinking of, then what I want to do now is I want to begin the repeated tasks that were inside the loop. So while user wants to continue adding scores, I should document my code as I go. So inside my loop, the first thing I want to do is prompt the user. If you look back at the pseudocode, you'll see we had a prompt. Let's look at it. There we go. We had a prompt, enter the score. We're going to retrieve the score. So enter score, and then we'll retrieve the score. Again, the scores themselves will probably be doubles. You can declare the variable for score right here. That's totally fine. What did I call my scanner? In. You can do that. I mean, we've talked about scope before with if statements. So variable scope, a variable is only visible in the block in which you define it. This applies to loops as well because they have a block. So this score variable is only visible inside the while loop. And for this example, that's okay. I'm actually not going to use the score variable outside of the loop. If I was, then I would declare it up here. For example, num scores, I need inside, and you'll see outside the loop. Same with total, right? That I need both inside and outside, so I declare them up here. Score, I don't need it outside, so I can declare it inside. Now, if you want to declare it up here with all of your variables, that's okay. And you could argue and say that's better because we always talk about how you have to think ahead to how you might modify your program. If I was going to modify this and use the score outside the loop, I would have to remember to undeclare it here and declare it up at the top. So you're going to say, hey, Wendy, you want to make this extendable. You want to make this easy to modify in the future. You should declare your variables at the top altogether. Yeah, that's a totally good argument. But I'm lazy and I like to put it in here. But if you were thinking that, you're right. It probably is not a bad idea to put it up here with the rest of your variables. I've just developed this habit of kind of declaring variables as I go, and I've done it so often that I don't generally forget to undeclare and redeclare because I do it all the time. But if you're more comfortable doing it the other way, that's totally fine. In fact, now that we're talking about it, it's driving me insane. So I'm just going to put it up here. All right, double score equals 0. There we go. Now you're happy. All right. So next thing I want to do, if I look at my pseudocode, I now want to add the score to the total and then increment my number of scores. So I'm going to take my total score, why not, plus equals, might as well use it, and add score to it. So obviously this is going to be retrieve a score, and then add, or we call this accumulate the score. And that would include also num scores plus plus, just like that. And then the last thing we wanted to do is we want to ask the user, do you want to keep going? And then we'll get the user's answer. Good. So we got to say, does user have another score? So we're going to do a little system.print. Another score. When you ask the user a question that requires input of a specific kind of answer, it's always good to let them know what kind of answer you're expecting. Just friendlier that way. Again, this is like old school console application stuff we used to do back before we had graphics and mice. We didn't have mice. We had to do everything with the keyboard. You had to memorize a lot of shortcuts. All right, my variable was called another, and we do the usual thing in .next, .to uppercase, .char at 0. And that gives me just the first letter, because that's all I care about. So I can't fit this all together, so I'm going to just come back through it again. So I created some variables. I haven't used all of them yet. We're getting there. And then I asked, And then I loop as long as the another is y. Now it's going to be to start with because that's how I initialized it, and that's okay. Then I retrieve a score from the user. I accumulate the score. I add the score to the total, and then I increment the number of scores. And then when I've done that, I ask the user, hey, do you have another one? And if they say anything that starts with the letter Y, we would loop back up to the top. Is another equal to Y? Yes. And we would ask for another score. We would add that score to the total, add another one to the number of scores, so it'd be 2. And then we'd ask the user again, do you have another score? If they say yes, I promise I'm only going to do this one more time. We would loop back up to the top and check, does another equal a Y? Yes, it does. We would ask them for the third score. We would add that third score to our total. We would increment to 3 the number of scores. And then we would ask the user, do you want to enter another? And maybe they're as bored as you are right now, and they're like, nope, I'm finished. So we would loop back up to the top. Is another equal to Y true? No, because they entered a no, an N. And so that means this is false. So we exit the loop. And now after, so that's why it's good to have these little comments on your braces. After the loop is over, so after all scores entered, we do the average score. So our average score, we did declare average score AVG score. I'm just going to copy paste that in case I type it wrong. Equals my total score divided by my num scores. There we go. And then I print it all nice and fancy. Average score, %.2f, \n, as always, average score. Just like that. So, there we go. So we can try it out. You can try like with, usually I like to do 3 inputs to test, and you can use a calculator if you don't want to do the math in your head. That's totally fine. I usually just enter really easy things that I can calculate in my head. So I'm going to, did I save? I did. Compile. And, oh, I got a bunch of errors. Cannot find symbol total score. What did I call it? Total score? Did I call it something else? What did I call it? Total scores with an S. Singular would have made a lot more sense, but that's okay. Did I spell it wrong everywhere? Yup. Line 30 and line 40. Okay, good. I'm just going to leave that error in there because I don't care. All right, save. Compile, oops, and execute. All right, so enter a score. I'm going to put 25. We're going to assume this is out of 25, not 100. And do I want another one? Yes. Notice I can type lowercase y. It's all good because I converted it to uppercase to make my life easier. And enter another score, 24. Do I want to do another one? One more. And 23. So 24, 23, and 25 should give me an average of 24 because it's right in the middle. Oh, I want to say no to that last one. And there's my average score. Let me just stretch this up so you can see the whole thing. There we go. So there's my average score, 24, all nice and formatted. So that's an example of, it's actually an indeterminate loop. It seems like a counted loop because we're counting scores, but it is indeterminate in that we don't know when we start how many scores the user is going to enter. So technically it's an indeterminate loop because before the loop begins, you don't know how many iterations you're going to have. So this is an indeterminate loop. Another loop in Java is the do-while loop. The do-while loop is a post-test or bottom-checking loop because the Boolean expression or the condition is at the bottom of the loop. You can see here by looking at the general form, we start off with the keyword do, and we have a set of braces. We've got a loop block, and the while is at the bottom, but it's after the closing brace. This can cause a few issues with your syntax in your head. It's quite common. So we've got while. Notice these keywords, just like with if statements, they're all lowercase. And then we have the Boolean expression in parentheses, and you must end this with a semicolon. You've been taught when we did ifs not to put a semicolon after the if header, and with a while loop, the same is true. We're actually going to talk about this in the very last video. This is the one where you do need a semicolon. Because the while condition is outside of the closing brace, you have to end this part of the statement with a semicolon so that Java recognizes this as part of the loop and not a piece of code that appears after the loop. Normally, any statement that appears immediately after a closing brace is a new statement, so we have to kind of put the semicolon here after the while so that it knows this is all part of the same loop structure. It's kind of weird and stupid. It's just the way it is. You'll get used to it. The more you type it, the less you'll have to try and remember. Now, a do-while loop is very similar to a while loop. In fact, if we trace this earlier example as a do-while loop, you will get the exact same output. So here we are again. I'm going to do the exact same thing. We're going to assume our user enters 4 for the value of num. It says that right there. So that's done. And I'm just going to check this off because the next thing we're going to do is create or define and initialize our count variable to 1. So now we have a do. So that means we're about to start a loop, but we don't have to check a condition at this time. We're just going to go in. So it's like if you go to the club and there's a doorman, so with the while loop, you had to check with the doorman first before you're allowed in. In this case, the doorman's not there. He'll check you later, right? He's going to find you when you're in the club and he'll check later. So there's no doorman. So we just go right into the loop. So the first thing we're going to do is we're going to print the current value of count, which is 1, followed by the colon hello, just like we did before. Again, this is print line, so every output is going to be on its own line. I think we pretty much got that. So there's the hello. Then I do my increment. So I take my count, I increment it to a value of 2. Then I hit the closing brace and I must do the while loop condition. So here's where I can now say, is the current value of count, again, there's that, less than or equal to thing. So there's the current value count. Is it less than or equal to num, which is always going to be 4 because it's never going to change. So currently it's 2. So we didn't get to compare the 1. That's okay. So we check, is the 2 still less than or equal to 4? That is true. So we are going to loop back up to the top, just like we did with the while loop, except this time the while was at the bottom. So we loop back up to the top and we are going to enter this loop again. We look at the current value of count. It's 2 and print it along with colon hello, just like before. And then we do the next statement, which is to take our count and increment it by 1 to 3. And then we evaluate or re-evaluate our condition. So we look at the current value of count, it's 3. Is it still less than or equal to num, which is 4? That is still true. So we go back up to the top of our loop and we enter it again. We look at the current value of count, it's 3. So we're going to print 3 followed by a colon, hello, just like that. And then we go to the next line of code, which increments our count to 4. And then we hit the bottom of our loop. We have to re-evaluate the while loop condition before we are allowed to determine if we get to go back up again. So we look at the current value of count, which is 4. Is that less than or equal to 4? Yes, that is true. So we get to return up to the top and we enter the loop again. We print the current value of count, which is 4. So we print 4 followed by hello. And of course, we then increment our count to 5. You know what's going to happen. So now we look at we finish the body of the loop. We reevaluate our condition. Is the current value of count, which is 5, less than or equal to num, which is 4? Obviously not. That is false. So now that means the loop is over, it's finished. So we just continue with the rest of the program. We have one more line of code after the loop that we have to execute. So after the loop is finished, we then print count followed by done. The current value of count is 5 followed by done. We actually get this exact same output for this program that we did for the other program. See? So we have the exact same output. 1 hello, 2 hello, 3 hello, 4 hello, 5 done. We have the exact same thing, right? All the exact same output. So a lot of the time, you won't see much of a difference between a top checking while loop or a bottom checking do loop. There is one significant thing that is different between the logic of these two loops. Take a moment to look at these two looping examples. These are two separate blocks of code. So what I want you to do is pause the video and take a moment to manually, just like you saw me doing, manually take the time to evaluate this loop and see what the output is. Write it down, then do this loop. It's exactly the same. Counter starts at 1, we print and decrement, so we're subtracting instead of adding, and the conditions are both count greater than 1. However, once you determine the output of the second loop, starting from scratch, so starting with count as 1, you'll see your output is different. So in the example we just did, the output was the same, but in this one it's going to be different. So pause the video, see if you can determine what the output is for each, and see if you can think about why is the output different, and then resume the video and we'll discuss the answer. Okay, hopefully you had a chance to try this out. So I'm going to trace them both, and then I'm going to run them both just to confirm the answers. So my first loop, I have my count variable and it gets initialized to 1. Then I evaluate the condition. So I'm looking at count greater than 1. So basically is 1 greater than 1? Well, we know that that is going to be false. So because this is false, it's going to skip the entire body of the loop, and if there was any code here, it would run it. So that means if we use this area here for our output, that means we got no output. So we didn't actually get to print anything with this first loop. When we look at the second loop, so now we're going to look at the second example. So again, we've got our variable count, and it's being initialized to a value of 1. And then we've got a do. So we enter the loop right away. We print line count. So we look up the current value of count. It's a 1, so 1 gets printed. Then, I'm right there. So then we decrement our count variable. So 1 minus 1 is going to be 0. So now count is 0. And then we evaluate our condition. So the current value of count is 0 greater than 1. So obviously 0 greater than 1 is false, so that means the loop terminates and the program is over. So with the first example, we got no output, and with the second example, we did get 1 output. This demonstrates the main logical difference. Obviously, syntactically, there's a lot of differences, but the main logical difference between the while loop and the do while loop. And this would be true of any top checking or pre-test loop and any bottom checking or post-test loop. And that is that it's guaranteed that your bottom checking loop is always guaranteed to execute at least once. And that's because the condition is at the bottom. That's why it's called bottom checking or post-test. Post means after. It tests after we iterate the loop. So because it checks at the bottom or after each loop iteration, it means that even if your condition is false right away, and it was before we decremented, count was 1, which is still not greater than 1. This was still false, but we didn't know that until we got there. So because the condition is at the bottom, you are guaranteed you will always execute the body of a do while or a bottom checking loop at least one time. Whereas with a top checking loop, if the condition is false right away, the body of the loop will never get to execute at all. That is the main logical difference between a while loop and a do while loop. So as an exercise, what I want you to do is rewrite the scores exercise we did earlier using a do while loop instead of a while loop. Pause the video and give this a try, and then when you're done, resume the video and I'll show you the answer. It won't take you that long, actually. It's really quick. Okay, so here's the solution to the exercise. Honestly, if it took you more than 60 seconds, you might want to go back and have another look at the do while. All I did was I basically just cut the while with the condition out. There it is down there. I just cut this out of here and then wrote the word do, and then I just pasted the part I cut after the closing brace and stuck a semicolon on the end. That's it. So if you run this, it actually runs exactly the same. So I compile, if everything is good. The syntax is a little wonky for the do while. I know it's a little weird, but you get used to it. So if I compile, let me just move this up here a bit. and I execute, so 25, yes, 24, yes, 23, no, I still get the same output. So it doesn't change anything, really. I mean, later when we do data validation, you'll see that you might prefer one type of loop over the other. We're going to talk about that later, but in this particular simple example, it makes no difference whether you use a top checking loop, a while loop, or a bottom checking do while loop. Now, how do you know if you should use a while loop or a do while loop? Sometimes it's not going to matter, so you can use whichever one you want in that case. But if you have a situation where you need to execute the loop body before you check the condition, then use a do while. It should be pretty obvious. For example, what if we wanted to write a program that asks the user a trivia question with a multiple choice set of options? So here I display my question with 3 possible answers to choose from, and I declare and initialize my variable to hold the user's answer before I start my loop. Again, you might be tempted to declare it inside the loop thinking I only need the user's answer in the loop, so it's best to declare it there. But this is another interesting thing about Java loops. We've kind of talked about this before. Because the while statement is outside of the closing brace, it won't have access to any of the variables that are declared inside the loop block. So we have to declare the answer variable above the do while. For example, if instead I went and did this and then tried to compile it, let's get this up here. There we go. It gives me this cannot find symbol on the answer on line 25. That's this line. So it's giving me that cannot find symbol that we've seen before. So again, you have to make sure that you watch the scope of those variables. So that's why I have to declare answer outside the loop. I just initialized it to the char null value. Unlike the previous example when we had I think it was called another variable, and we initialized it to the letter Y so we could get into the loop, it actually doesn't matter when you're doing a bottom checking loop. This is one of these other little things that makes a bottom checking loop, like a do while, different from a top checking loop, like a while loop. So it doesn't matter. You'll see why in a second. If you don't see it now, it's okay. But you'll see why in a second. You could initialize this to any valid char value. It's not going to matter, because once we declare answer, we then see the loop and we enter it right away because it's a bottom checking loop. So we print a prompt to ask the user for their answer, and then I retrieve their answer as a char. So it doesn't matter what I initialize this to, I'm going to overwrite it anyway when the user answers the question. And then my loop says, the answer, by the way, is B. So the loop says when or while the answer is not the letter B, we are going to repeat asking and retrieving the answer. So while the answer is not B, we are going to ask again. And if they answer something else, while it's not B, we'll ask again. We're basically going to repeat these 2 statements until this is false, which means they will have entered the letter B. And then once this is false, that means they did answer the correct answer, so we can then say, well done. If we now save, compile, and I need to save, compile and execute. There we go. So before Java was called Java, it was called, maybe you're hungry or you want some coffee, so you might say the letter A. Again, it doesn't matter if I type upper or lowercase because I took care of that here. So I'm going to enter the letter A, press enter, and it's obviously not correct. It just said answer again. Oh, it must be wrong. Let's try C. C sounds familiar. Gosling? Nope, that's not the answer either. Okay, well, there's only one left. The answer must be B. So I type a B. What's going to happen is this is now going to be false. Is B not equal to B? No. So that's going to be false. It's going to exit and it's going to print well done. Ta-da! There we go. So that's one good use for a bottom checking loop. However, what if I wanted to give some more specific feedback to my user? So here it just, if I got it wrong, it didn't tell me it was wrong. It just asked me again. So I'm like, okay, it must be wrong. I'll try again. So I had to kind of assume. But you want to make sure you're a little friendlier to your user. So you might want to instead say something like, if they answered it incorrectly, say incorrect, try again. Otherwise, then, go ahead and say, yay, you're correct. Well done. So if you've done some programming before, your first instinct might be, oh yeah, I'll just put an if statement in here and say, if they said the letter B, great, say correct, but if they didn't, say, sorry, that's incorrect. That is an okay solution, but it's not as efficient as the solution I'm going to show you. What I want to do is I want to ask the user for their answer first, and then I want to repeat only if they answer wrong the first time. This is going to use a pattern called the priming read, continuing read pattern. And it's going to involve using a top checking loop instead of a bottom checking loop. So I'm going to erase this part of my code and start over. So the first thing I'm going to do is what we call the priming read. This basically means I'm going to prime, actually I don't need this either, I'm going to prime the answer variable with the user's first input. So I'm going to do the print that asks for the answer, and then I'm going to grab that as a char. I'm going to reuse that. There we go. So I am priming my answer variable with the user's first input. Then I'm going to do my while loop. I'm going to do a top checking loop. So while the answer is not equal to the letter B, then I know that it's correct. It's not an if statement. I'm not checking it only once. I'm going to check repeatedly. That's why I'm using a while loop. So what I'm going to do inside my while loop is while the user has not answered correctly, I'm then going to display my incorrect, and I'm going to, ask them to enter a new answer. So I'm going to ask them to try again. This is what we call, this piece here is called the continuing, got to spell it right, the continuing read. It's still not spelled right. Continuing, yes it is. So the continuing read. So when I display the incorrect message, I'm prompting them to enter a new answer, and then I'm retrieving that new answer. It's called a continuing read because this is going to determine whether this loop continues or not. The whole point is that when you do any kind of loop, whatever variable or expression you're using as the loop's controller, the thing that's controlling how the loop continues or terminates, that variable or expression needs to change on every iteration. If it never changes, then you're going to end up with an endless loop. It's another way to come up with an endless loop. So here I do my continuing read to ensure that at some point I get something that is going to make this condition false, and that will then terminate the loop. So the continuing read is really, really important. So once I've done my continuing read, after the loop is over, what will happen is I can then print my correct well done, because if the user enters an incorrect answer the first time, my loop condition will be true. It will come in and print the incorrect try again, retrieve a new answer, and then it will reevaluate the expression to see if the new answer is the letter B. If it's not, it's going to repeat this. Eventually, we hope, if the user is smart, they will eventually get the correct answer, and then this will be false. When this condition is false, it means they answered correctly. The loop will terminate, and that's when we can display our correct well done. Let's give it a try. Save, compile, execute. So there's our trivia question. So I'm going to answer A, which we know is incorrect, and it says incorrect, try again. So I'm going to try C, and of course incorrect, try again. Now I'm going to try B. That means B not equal to B. That's false. It's going to then finish, and it's going to print correct, well done, just like that. So there's a couple of examples where you might choose a bottom checking loop over a top checking loop. And it's also a good example of a very popular pattern called the priming read, continuing read pattern. Here's another exercise to try. Write a program that uses the priming read continuing read pattern to calculate the average semester grade for a student. Ask the user for each of their final grades in a term. Now, we don't know how many courses the user took, so we'll just use a sentinel value to terminate the loop. We've talked about sentinel values in a previous video. In other words, when the user is done entering grades, they'll enter a negative grade. And this works fine because we don't assign negative grades, so that's a great sentinel value. Now, be sure you tell your user this so that they know how to quit. Go ahead and pause the video, don't forget your IPO chart, try the programming question, and then when you're done, come back and I'll show you the answer. Okay, hopefully you had a chance to give that a try. You'll find this program is very similar to the average score program we wrote earlier, and that's okay. It gives you more of a chance to focus more on the priming read continuing read pattern, and it gives you more practice with loops. So, of course, we do the output first. The output is the average grade. In order to calculate the average, we need each of the final grades that the user has, and the processing, like before, we add each grade entered to a total, and then after all the grades are entered, we then calculate the average as the total grade divided by number of grades. Again, you're going to find the logic for this is almost exactly the same, at least some of it, as the previous example that calculated the average. Okay, this one probably required a bit of thought, but it is totally doable. So in this one, of course, I set up my total grade and my number of grades right away. We didn't need anything for continuing because we're going to use the grade for that. We're using a sentinel. So this is where things are a little awkward, but like I said, it's just a good exercise in thinking logically. So I asked the user for the first grade. This is my priming read. Now it is possible, I mean, it's probably not likely, but that doesn't mean it's impossible. It is possible that the user might enter a negative grade right away, in which case, you know, there's no average to worry about. So I check right away if the grade is greater than or equal to 0, it means they want to continue. So if it's greater than or equal to 0, I take the grade they already entered first and add it to my total, and then I increment my number of grades because I've got 1, so I add 1 to my counter. Then I do my continuing read. I ask for the next grade they want to enter. If they just entered 1 and they're like, nah, I'm done, I want to quit, they'll enter a negative number, and then this will be false and we'll terminate. But if not, if they enter a positive number, then when we loop back up to the top, this is still true. So we're going to take that newly entered grade and process it, and then we'll ask for the next grade. And we repeat until eventually they will enter a negative grade. That will cause this to be false because it's no longer greater than or equal to 0. And then after that loop is done, we can then calculate the average and print it. So if you run this again, let me just make this a bit bigger. And again, I'll just enter, this one's nice because you don't have to do the like, do you want to continue? Just do 25, 24, 23, and when you're done, enter anything negative, and it calculates the average of 24. Now, you might have had to spend a little bit of extra time trying to figure out the logic for this one, and that's a good exercise. It is a bit awkward. This is probably a good example where I might prefer to use a bottom checking loop for this one. So an extra exercise, if you wish, could be to rewrite this program using a bottom checking loop and make sure you test it out and that your output is correct. Now, the while loop and do while loop are the loops that we use for indeterminate loops. You can also use them as counted loops, but the for loop is a more popular choice for a counted loop because it actually automates a couple of the tasks. For example, recall this while loop example that we looked at in the very beginning. This is an example of a counted loop. The loop starts iterating when the counter is 1, and it stops iterating when it reaches the user's input value. So it executes a specific number of times that is determined before the loop begins executing. Now, many programmers would prefer to write this as a for loop. In Java, the for loop is the counted loop, and it looks just like this. The initialization is a short statement or expression that initializes the counter that your loop is using. You can declare the counter variable at this point if you wish, but note that the variable scope will be limited to the for loop. The condition to continue is any valid Boolean expression or condition. As long as this expression is true, the loop continues. So that means it acts just like a top checking while loop. The increment section, which doesn't actually have to increment, as you'll see when you do the extra exercises in the notes, is the expression that executes at the end of each loop iteration. This expression is what keeps the loop going, but it must adjust the loop counter so that eventually the condition to continue becomes false so that the loop can terminate. Let's look at an example. This is how the previous while loop example would appear as a for loop. So let's trace it and see how it works. As we did in the previous versions, we're going to assume that the user enters an input value 4. So let's go ahead and create the num variable and assign it the user input value 4. And we start our for loop. The first thing that happens when you begin a for loop is you declare and initialize your counter variable. Hooray! So this is all done automatically. So we create our variable count and initialize it to the value 1 because that's what it says. The next thing that we do is we now evaluate our condition, just like we did with the while loop. So our condition is count less than or equal to num, which is always going to be 4. That's never going to change. So we look at our current value of count. It's a 1. So 1 less than or equal to 4, that is true. Then we go into the loop. We don't do the count plus plus yet. So we go into the loop, we see a print line, count concatenated to hello with a colon. We know what this is going to do. So 1, because that's the current value of count, followed by hello. And that is the only statement in the body of this for loop. That means actually that as with ifs and stuff, if there's only one line of code in the loop block, you can leave off the braces. But as I've said in the past, I wouldn't recommend doing that because it makes it really easy to make errors, as you'll see in the last video in this series. So once we finish the body of this for loop, we loop back up to the top. And the next thing that we do is, because we just finished an iteration, we now do the increment expression. The increment expression count plus plus executes at the end of an iteration, but before the next iteration begins. So this now increments count to 2. Then we do the re-evaluation of our expression. So we re-evaluate, is the current count, which is 2, less than or equal to num? Yes, that is true. So we get to re-enter this for loop. We're going to print the current value of count, which is 2, followed by hello. Just like that. Then this finishes the body of the for loop again, so we loop back up to the top. Before we can reevaluate, we must increment our counter. Always do the increment expression before you begin a new iteration of your loop. So we increment count to 3, and we check our condition. Is count, which is 3, still less than or equal to num? Yes, that is true. So we're going to go into the loop again, and we're going to print the current value of count. I lost my cursor. There it is, which is 3. Hello, kitty, who just jumped in my lap. Sorry. I don't know if you heard that. So we print 3 hello. And then that finishes this iteration. We loop back up to the top of our for loop, and again, we have to increment our counter before we can do anything else. So we take our counter, I'm just going to go up here, and we increment it to 4. Then we begin a new iteration where we re-evaluate our condition. So we look at the current value of counter, which is 4. Is 4 still less than or equal to 4? Yes, that is true. So we're going to go into our loop one more time, and we're going to print the current value of counter, followed by colon hello. And we can see, obviously, this is going to finish, but the program doesn't see that yet. We loop back up to the top. We're at the end of an iteration, so we need to do our increment. We have to, otherwise we would keep going. So we're going to increment this to 5. Then we can begin or attempt to begin a new iteration by re-evaluating our condition. Is the current value of count equal or less than or equal to 4? No, this is now false, which means this loop now terminates. So logically it executes just like a while loop, just like a top checking loop, but we don't have to do the incrementing ourselves. It's actually part of the for loop, which is kind of cool. And we can tell it to declare and initialize our counter variable if we want to. Now note that if I wanted to include the extra statement that was after the while loop, it's kind of covered in pen here right now, but you probably remember what it was. So if we had the print line count, if you tried that in your editor, you would get an error. We saw this error earlier actually for the same reason when we did, I think it was the another variable or the answer variable. So this variable is local to the for loop. So that means this is not defined. At this point, you'll get the cannot find symbol, and that's because it's local to this for loop. So if you needed, usually you don't, but if you needed your for loops counter outside of the for loop itself, it's easy to fix actually. All you do is, here's the exact same code with that fixed, is you would declare, and unfortunately you still have to initialize your counter variable before the loop. It's a little bit redundant because you do have to declare it, but because of Java being Java, you are also forced to initialize it even though you're initializing it here in the for loop anyways. That's just the way it is, unfortunately. It's something you have to deal with. So we declare our variable outside the loop, and that means it's now visible outside the loop. So it's visible after the for loop. So that's how you can fix that issue. But I think most of the time, you actually don't need your counter outside of the for loop. So it's generally not that big of a deal. Okay, here's another exercise. See if you can manually determine the output for this for loop. Go ahead and pause the video, try to determine it by hand on your own, and then resume the video to check your answer. Okay, hopefully you had a chance to try this out. One thing you're going to notice, especially in your textbook and in tutorials online and stuff, is it's really common to use the variable I in a for loop. I know we talk a lot about self-documenting variable names. This is actually one of the situations where it's okay to use a variable name that isn't really self-documenting. In fact, when you learn to use NetBeans Editor next semester, it has a lot of autocomplete code. There's a little trick. You can just type the word for I in NetBeans and it will put a whole for loop into the editor for you, and it always uses I as the counter. It's that common. It's very common to use I as a for loop counter, so you'll see it a lot, so don't panic. So if I'm going to trace this code, I declare I and initialize it to a value of 1. And then again, when we begin the loop, we not only declare and initialize our variable, we also are going to evaluate the condition. Hey, it's possible this condition right here could be false when we start. That's possible with a for loop as well, but not in this case. So we want to check and see, is the current value of I less than 10? Right now, that's true. So we're now going to go into the loop. Ooh, we've got a printf. So we're going to print a %d, that's a format specifier for an integer, followed by a space. Basically, we're printing the letter I followed by a space, but no new line. Okay, so we're going to print the current value of I, which is a 1. I'll do a little underscore as a space so we know it's there. And this is a printf, no new line. So our next line of output is going to go right after that space, so we don't want to forget. Then we loop back up to the top. And before we can go any further, we have to perform the increment statement. I said before, you don't always have to increment by 1. If you want to increment by 2, you just do I plus equals 2, like this one does. If you want to decrement, you can use a minus minus. If you want to decrement by 1, if you want to decrement by something other than 1, you can do a minus equals. This is where we see a lot of these augmented assignment operators, if you want to increment or decrement by something other than 1. So I plus equals 2. So I'm going to take the current value of I, which is 1. I'm going to add 2 to it, and I'm going to have 3. Oh, we saw this before with an endless loop, but this is how you would write that loop correctly, but as a for loop. So I've incremented I by 2 to a value of 3. I now reevaluate my condition. Is 3 still less than 10? Yes, that is true. So I'm going to go inside my loop again, and I'm going to print the value of I with a space after it. We left off right where that arrow is, so we're going to print 3 and a space after it. Then I loop back up to the top. Before I can continue my loop, I must do the incrementing. So I'm going to take my value 3, whoops, I'm going to increment it to 2. That's going to give me a 5. So now I is 5. Is I less than 10? Is 5 less than 10? Yes, that is true. So I'm going to go inside my loop, and I'm going to do my printf again. So I'm going to print the current value of I, which is 5, followed by a space. Again, this one, it's all printf, so it's all going to be on the same line. Then I loop back up to the top. Before I can do anything else, I have to perform my increment. So I'm incrementing 5 by 2, so now I is 7. So is 7 less than 10? Yes, this is true. So I'm going to go inside my loop again. I'm going to printf my value of I with a space after it. So it's going to print 7 followed by a space. And then we loop back up to the top. Before we can do anything else, we have to increment our I by 2. 7 plus 2 is 9. So our new value of I is 9. Then we check our condition. Is 9 still less than 10? Yes, that is true. So we're going to enter our loop. We are going to execute our printf. We're going to take the current value of I and format it nicely with a space after it. So 9 followed by a space. And then we're going to loop back up to the top. And before we can do anything else, we need to do that increment statement. So we're going to take the current value of I and add 2 to it. That's going to make I have a value of 11. Now we attempt to begin a new iteration by re-evaluating our condition, which is I less than 10, 11, because that's I right now, less than 10. Is that true or false? That is false. So now the loop terminates. So because this is now false, we terminate the loop. If there was any code after the for loop, it would execute, but there's nothing. So that means we're done, and there is our output, 1, 3, 5, 7, 9, with a space in between. Here's one more exercise for you to try. So again, it's a programming exercise. So write a program that displays a times table for a user entered value and multiply them 1 to 12. So for example, if the user enters 12, then this output here is what your table would look like. Now note the formatting, specifically the first and last columns. Notice that they're right justified, lined up on the tens column. So you're going to be using your printf for that. Go ahead and pause the video, give this a try, and then resume the video and you can check your answer. Alright, hopefully you had a chance to give that a try. Let's take it up really quickly. So our IPO chart, this one's pretty easy. So the output is the multiplication table from 1 to 12. What do we need to know? We need the user to enter the value for that particular table. So 1 times whatever, 2 times whatever, so the whatever part. And the processing, we're basically going to have to use a loop to multiply each number from 1 to 12 by the table value that's entered by the user. So I started the program, I've got my scanner, and then I'm retrieving the table value from the user. I just called it value. Obviously we're working all with integers. If you look at the output, you can clearly see it's all integer output, there's no decimals. And I want to do my for loop. So my for loop, first I need a counter. Here, let's just use I. And if we're counting, you have to think about what we're counting. If you look at the required output, you'll see that we're taking, if 12 is the input from the user, we're taking each number from 1 all the way to 12, and we're multiplying. So that probably means that our counter in our loop is going to go from 1 to 12 inclusive. So that means I'm going to start my counter at 1, and I'm going to continue as long as my counter is less than or equal to 12. So I'm starting at 1, and I'm going up to and including 12. If I did just less than 12, that means it would go from 1 to 11, which I don't want. So I want it to go from I equals 1 to I less than or equal to 12. And what am I doing to I on each iteration? I'm just incrementing them by 1. Nice and easy. And then you can do this however you like. I actually did it in one line of code. I just did a little printf. And what I want to do is I want to display, this is where one of these charts would come in handy. I want to display the output just like I see it here. So you can see that in the first column, the maximum value we have is 2 digits, right? So some of them are 1 digit, some of them are 2 digits. So my first column, obviously these are going to be all D's because they're integers. So %2D. Then a space, and then the letter X because that's the time symbol, and then a space. And then the value, the user could enter any value, really. They could enter a single digit, they could enter 2 digits, or even 3 digits, but I think most people would do 2 digits. I suppose we could add some validation later and say, you can only enter up to 12 or 20 or whatever. So let's just, for now, assume 2 digits. So %2D again, a space, an equal sign, a space. And then for my last column, the maximum I see here is 3 digits. I guess you could go as high as 4, but again, maybe we just, in grade school, we just did 12s times tables. We never went past, was it 12 or 15? Now I can't remember. But anyway, I would just assume there's probably not going to be more than 3 digits in the last column. So %3D. And that'll ensure, don't forget your new line, that'll ensure all these digits are right justified, lined up at the tens or the imaginary decimal point if we had one. So 2D, 2D, and 3D. So for my format specifier, that's exactly what I'm going to put. %2D space x %2D space equals space and then %3D. Don't forget the new line at the end. And here's the good part. So what value is going to go in the first format specifier? That's the value in my first column, which you'll see is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's my counter. So my first format specifier is going to be my counter value, which is I. My second %2D, that's the second numeric column. And that's the column with the user's value. So if the user entered 12, it's going to be 12. If they enter 5, it's going to be 5. And so that is the value. And that makes the last part easy. So the last part is going to be the counter, so the current row number, times the user entered value. So you don't have to store it in a variable if you're just going to use it once. You can just do it like that. Oops, we need one of those at the end. There we go. So if we save, compile, and execute, there we go. And if I enter 12, there's my 12 times table. Look, it's all formatted nice. There we go. You can try this out with other values if you want. You can play around with it if you want to get really high values. You might want to change some of these format specifiers, but that's fine. And that's a good example of a for loop. So that's an introduction to looping. Now make sure you do all of the practice exercises in the notes and in the textbook so that you become very familiar with those 3 loops, because in the next video we'll look at nested loops and other nested structures, and you're going to need to be familiar with your loops in order to do that. So I'll see you over there. Thanks for watching.